So we're doing the can crusher, and we by myself, BJ, Alan, Dushan, Daniel, and I think Alan will take it away.
So our aim for this goal was to make a reliable and consistent product to hopefully aim to satisfy our clients' needs, which was to create a lightweight, simple design capable of crushing cans and having them stored for a long time. Yeah, due to our increasing use of materials, land waste and sustainability have been a real issue lately. So to help the landfill issue, we are looking into increasing the ease of recycling of aluminium cans in specific. To encourage citizens, a monetary incentive, so like a fine will be dispensed after the use of the product. So the can is usually, with the smaller ones, like about 115 mil in height. Larger ones are 155 millimeters in height. Our goal is to crush these down to approximately 15 mils. And for safety issues, we don't want anyone to be using the disposal as like just a normal rubbish bin. So we use a detector to make sure it's actual legitimate cans. So with the containing of these cans, without reliable data, we didn't really do any research into specific areas, but we may need to increase or decrease storage space to fit the required amount of volume. And with our constraints, we usually want the product to last a set amount of time before we need to replace them. Our goal is to keep them around 6 months before we need to do any big repairs, and then they should also be able to contain enough cans for a week. The construction of the general frame should be sturdy to protect the mechanism inside for a long period of time to meet our expectation of 6 months before repairs.
So when it comes to sharing and completing group tasks, we use Discord as our communication method. So we chose Discord as it's pretty commonplace and everyone around us already knows it. And you can transfer files, especially the ones that are smaller, so a few megabytes or less. And so it was our go-to choice for using our communication with software.
And also Google, the Google Docs and Google Slideshow.
Yeah, Google.
Google Docs to collaborate.
So this is just one of our meeting minutes. They're all pretty similar. So we've just mainly listed what we've done, needed to do, and who's doing what. That's good.
So we have some competitors for our design, considering that there's many of these designs out there. So our first one is a patent that was published in 2009. We adapted the same level of design that Ron designed from this patent. The cylindrical body we kind of scrapped due to it not being very easy to mount on walls or find in different areas. So we used a rectangular square-like body just to make it more sturdy and be able to mount itself on surfaces of various kinds, so concrete, rock, wood, that sort of thing. So this is just one of the designs that we implemented. The second one is very similar. This one is a wall-mounted design, so this one has the railing in the back which can be screwed onto the wall. This one also has a cylindrical body which we can use, and we also scrap the use of a spring. This one has a different lever arm design which has like 2 stages when crushing it. So this has a different fixture that we sort of adapted with a secondary hinge.
Yeah, so we constructed our needs analysis, and it's 6 pages long, but I cramped them down into the small areas just to explain. So one of our main needs was efficiency in the competitors market. So as well as the customer's needs, we wanted something efficient and that's constant, that's flowing well. And going into flowing well, our functionality, we wanted something that was universal use and nice and easy to crush without effort, to make the customer satisfied and apply for the client's needs. And the complexity, we wanted it to be simple with that universal needs. Like, so, it should be like as minimum effort as possible for our customer. And yeah, legality, like John was saying about all the other designs out there, we wanted to make sure that none of ours was copied in any way or was similar. And yeah, then materials and physical size, we wanted something like that, so it was able to move and be nice and light. And yeah, and for our prototype, we're using 3D print, but we're planning to use aluminium and I think stainless steel. And yeah, so then from these needs, we mind mapped. So we did a mind map, and we grabbed our needs and we expanded on that. So you got this safety, complexity, functionality, and all the other things on our needs list that we expanded, and then we did it even more in-depth mind map, which is this one, where we look at the aluminium can properties. So like for that, for that simplicity, how much torque does it need to crush? The materials, so what materials have we got and what can we use? And then, for our clients, we've got cost effective and scope, which is what we were going through earlier. And then for sustainability, we go down to our recycled components, which is our can, and then our materials for our actual design goes back to our properties of what we can look for in our different materials we have. And then safety was a big one that we'll see later on in our QFD. So our design safety, we have a lot of moving compartments, so you need this to get traps or the sharpness of the can. So we wanted to make sure that everything was safe, especially production as well, and mainly efficient. We have a large area because we want to make sure that it's different from all the others and make sure it's good. So, yeah, let's go to the next one. And then from leading on to that, we go to our specifications. So the height the client one was from 115 to 155 millimeters height and 66 millimeters diameter. And yeah, so we wanted something light that goes down to the size of physicalness. And yeah, and then this just goes into more detail about like how much torque and the crushing strength that you'll need to crush it. And yeah, I think this was 2 pages long too, but we just did 1 page. Yeah. So then this is our QFD that we did. So the small arrows indicate it's not as important. It's going down, and then the circular ones is the medium, and then the arrows going up is relevantly important, and the circles is really important. And then if we go, and then we compared all of ours to our components. And if we go to the next page, we realise that component 1, this is all of our numbers right here. It's just the scale, so you can see. So we realise as we go into the component zone, like we have our big main things, which is safety and materials. Then we got budget, functionality, and efficiency. And these ones, and efficiency and functionality work hand in hand, which is what we were trying to aim for our client. And yeah, I think
So this is the work breakdown structure. It's a little bit non-intuitive, but it does make sense. So we have our main stages of where the components that we'll be working on. So we broke the initial idea down to the point incentive mechanism, the detection mechanism, so whether it's a can or not, the actual crushing mechanism, so the piston or the electric pinion that we'll be using to crush the can, and the storage mechanism, so where the cans will be stored once it's crushed. These arrows that are leading down, these are the more specific sections of each group, and they're linked together based on significance and relations. So, for example, the top arrows will link to the parent modules. So the parent modules are modules that every aspect of the design are like related to or that reliant on. So we have the product dimensions, which determines all the aspects of the design. So that's a relationship. And here is the same process. So the arrows that go from the second last module back to the relationship is the same thing. The electrical side of things are not really well established in our product design. We decided to remove this to some extent due to design changes and specifications. And with our main electrical component, which is the user interface, where the person will be accessing when crushing the can, whether it's automatic or not. That one, we have extended it out so that we talk about the actual user interface, what is going to be shown to the actual person when the can is being crushed. And then the display screen itself, the physical size, shape, and where that's going to be. And then we have this storage basin, so we're mostly likely to have to make some separate compartment where the crushed can will be stored. And it's a predefined process, so what that means is that once it's crushed, it will automatically be put into the storage area once it's already been completed. And the same storage compartment can be removed and accessed by somebody else that might be repairing or operating with maintenance with the equipment, so that it can be clean, and that very box with all the cans and stuff can be sent to a recycling facility where it gets recycled.
Here's concept one. So the main goal that we had when we made this was really simplicity. So as you'll see through all the concepts that we go through, they're more building off of each other and trying to go for a more simpler design. And here is the, well, as you can see there, is the final design that is the most simple, in my opinion. And it has 4 really working parts, which is the lever, the cylinder in the middle that goes down and crushes the can. This is part of the lever, and then there's the piece that connects the lever to the mechanism. At the moment, we don't have a pusher system. In the end, we were supposed to have a hole here where a pusher will remove the can when it's crushed down to 15 millimeters and put it into a basket. So the thing with having a cylinder that all the other competitors had, that I found, was that it was very hard to expand off it and have extra things. So with this rectangular design, we've added the ability to have a mechanism that will detect if it's a can, so that they can't put a plastic plate in, and also a coin mechanism that gives you incentive to actually crush the cans, because if you put the can in, crush it, get a coin out, more people want to do it. So here was the design before, which made me realize that the old can crusher is not a good idea. So in this design, the whole top part was supposed to crush the can, which works with concept, but because of that, you can't have any systems that detect if there's actually a can in there, because it's very hard to put a system in when the whole thing is moving down and can crush the whole system. Other than that, it's basically the same. That was the only design that was changed from 2 to 1. And then this one, it's basically the same as 1, except because it's a gear system, it's a lot less simple, and the maintenance time and all the parts that will need to be replaced is a lot higher. Because there's a gear system, there's a lot more moving parts, and also it's going to take a lot more time to crush each individual can when you have full pressure, because also if you need to do it in one snap, there's a lot higher chance that someone's hand get caught and broken fingers. No good. And then the next one. This one was kind of a bit more experimental, and we wanted to flip it on its side basically, where the lever will push it across and squish the can up there and then falls down. We incorporated similar aspects into the final design, but it was probably the best design one. And that's my quick design one. It meets the needs of the client. It can be adapted to a wall, and it could also be on table, whatever you choose, to be honest. It's extremely lightweight because there's a lot of open area. The heaviest part really will be the cylinder, which is the part that needs to be heavy to actually crush the can. It's extremely easy to use. You just need to pull handle it. It's easy to repair because there's only a few parts. It doesn't really, you can take it apart really easily. It's really efficient, because same reasons, and there's no, as I said before, because there's no electronic parts, it increases the efficiency of the lifespan. And there's the final 3D model. This is a tiny bit smaller from constraints of the 3D printer. It can only be 200 by 200 by 200. This is 400 by 200 by 200, which is too big, so we had to minimize the housing. So,
So for production sustainability, because our main goal was to be sustainable, one of the aspects we're looking to, which will cover soon, is the materials. So when the cans are crushed, we could use the cans materials to make more of this product. So it's like a cradle to cradle kind of thing. So we can use the crushed cans, once recycled, use that raw material to make more of the same product. So in essence, the energy required, the processing time, and the production for this product alone will be cheaper, less time consuming, and there are less stages where there are more likely to be problems, and the whole chain when it comes to building this product from raw material to the final will be less, so that the client who might want to invest in this product might spend less money on it and be more likely to put more investment into it and for its future development. So this is the bill of materials. So we have the number of parts, and each part has its own metal that we might be using. So for the lever that we'll be using for crushing the can with the hand with meat is made of aluminium, same stuff that the cans are made of. And the double point rotating rod, which is the conrod that connects the piston to the lever, that one is likely to be made out of brass because it needs to be heavy, or the same aluminium depending on which one is cheaper or which one is more suitable for the job. It has to be smooth because you need to slide in the compartment. If you cannot, it gets jammed. Then the ram itself, which is the cylindrical component, is made out of brass and out of aluminium, which does the same thing as the conrod. Both the rod and the piston run hand in hand, therefore they have to be made of the same material. The chassis or the body of the frame of the actual product is to be made of aluminium. It doesn't need to be too sturdy as the product itself has compromises to meet their standard.
Our Gantt chart. So the reason why they're so blocky was because we did them during the period of the week. So our due date was at the end of each day. And the reason why it's cinder block was because we're working together and collaborating slowly. But our first meeting was to get everything started so that we could plan everything, which was our scope, mind map, and our cover sheet for our report that we're doing. And our report is later down the process. And then, coming into the second week was our going through our needs after our mind map, like I was saying, going through our specifications table, needs analysis, and making our Gantt chart, which is almost done, as we've got production needs to be decided. So then after that we did our sketching and our designing, and then we have our prototype, which is halfway there. We still got to test it, and we've also we haven't made full scale yet, so it's halfway done. That's about it. And the green means like that it's in the process or it's already done.
So this is the research and design solution structure that we all followed during the process of making this design and the research at the top. So we have our research questions. So when we start off our design phase and the initiation of the project, we had a question and one answer. And then we do online research or a book research of any kind of that particular question or research idea. And whether if the problem that we encounter is solved or isn't, we start the process again if it isn't, and we'll implement it if it solves the problem that we're having. And that's it.
Did you actually have meetings at 4:10 a.m.?
4 a.m.? Yeah.
That's what I was laughing. Because why did you wake up so early? I didn't get it.
No, who said we went to sleep?
Who
decided on the 4:10 a.m.?
Yeah, I may have made out of misread that at the log PM.
No.
Okay. Can I ask you to introduce yourself one more time?
I'm Daniel.
Daniel?
BJ.
Alan? You know what? There are two situations for a teacher. One is when you are not much, how can I put it? The moments which you are not very much proud of, sometimes you are more proud of having students. And this class is neither of those. That's the one which is the most I'm proud of being involved in. And you just look, I'm a passionate teacher, and this is just because of the students like you that I get the job satisfaction. I'm really happy to be involved with your class. So yes, all I can say is thank you. Thank you. You made my day.
Thank you.
Thanks.
Yes, very good. Yeah.
Fair enough. Alright, you're about to bring that down. Sorry.